Very good morning, everyone. This is our subject, Advanced Calculus. This is the mathematics subject which we will study in this second semester. And the main thing is, in order to do any problem in this subject, you have to learn the formulas in integration and differentiation. In each and every problem, you will encounter integration or differentiation. So without the knowledge of integration and differentiation formulas, you cannot do a single problem in this subject. Okay, so first learn the formulas in integration and differentiation. Okay, that is very much essential. So as you know, there are 5 units in our syllabus. The first 2 units comes under differential equations. First 2 units comes under differential equations. So in particular, in the first unit, we'll study about ordinary differential equations. You studied some of the methods to solve first order differential equations in the intermediate itself. Okay, you learn those methods also, and we'll learn some other different methods to solve first order differential equations. Okay, so first of all, this is our subject, Advanced Calculus. Next. First, this is the unit 1, first order ordinary differential equations. So here you will encounter these ordinary differential equations or differential equations in your engineering problems. If you want to solve any problem involving physical nature, so first we have to express it in mathematical form. First, mathematical formula express reality. That mathematical form involves variables, functions, and equations sometimes. For example, dy by dx plus x equal to 0. In that form, we'll express the given problem in terms of a differential equation. If it involves a rate of change of one quantity with respect to another quantity, that is, if it involves the derivatives, we'll express it as a differential equation. So that is nothing but a mathematical form. We'll call it as a mathematical model. Next, the formulation of that given physical problem in terms of differential equation is, we'll call it as a modeling, a mathematical model, or the process of forming a mathematical model is nothing but we'll call it as a modeling. Okay, so these differential equations will arise when there is a rate of change of one quantity with respect to another quantity. For example, you know that velocity is a rate of change of displacement. Rate of change of displacement. It involves derivative. So if there is any problem related to velocity, you will get a differential equation related to it. Similarly, acceleration. A rate of change of velocity is nothing but acceleration. It involves a derivative. So problems involve acceleration it can be formulated as a differential equation. Okay, so hence a model is often that is a model containing derivative is called as a differential equation. Differential equation. So this is the process. In engineering problems, we'll convert a physical problem into a differential equation. We'll formulate a differential equation from the given problem. We'll call it as a modeling. Next, you'll use mathematical methods to solve that differential equation. We'll use mathematical methods to solve that differential equation. Then you will get a solution for the differential equation, and we'll interpret the solution. We'll interpret the solution in terms of the given conditions. Okay. So in this, we'll learn the methods to solve the differential equation here. Mathematically here, we'll learn the methods to solve the differential equations here. In particular, Here we will study about first order differential equations. So this is the example, real-time example in which we will get a derivative. For example, the problems involving these type of circuits. Okay, that is, if you consider the problem like this, it will be converted into a differential equation like this. It will be converted into a differential equation using okay, the laws in electricity. Okay, so L into di by dt is the voltage drop across the conductor end. This is the conductor. The voltage drop according the voltage drop across the conductance is given by L into di by dt. If I is the current and t is the time, L is the conductance, and R into I is the voltage drop across the resistance. The voltage drop across the resistance is given by R into I. The voltage drop here is L into di by dt. Okay, so using the laws here, the sum of these two voltage drops is equal to total EMF. That is L into di by dt plus R into I. This is the sum of these two voltage drops. This is equal to EMF and E. So from this, we have formulated a differential equation. Okay, this is an example where we will get a differential equation from the physical problem. Physical problem means differential equation ela form avutundane daniki just example la chupistunana. Okay, don't worry about it. Okay, so our aim is to solve this type of differential equations in this unit. Okay, so from the physical problem we will formulate a differential equation. Okay, now here we will learn the methods to solve that differential equation. Next step is we will interpret the result. Okay, interpretation of the result. Okay, these type of differential equations arise when there is a rate of change of one quantity with respect to another quantity. What is the derivative rate of change of one quantity with respect to the another quantity? The changing variable is called as a dependent variable, and the other variable is called as the independent variable. For example, in dy by dx, this is the rate of change of y with respect to x. Here y is called as the dependent variable. X is known as the independent variable. Remember this carefully, that in dy by dx, y is the dependent variable and x is the independent variable. Remember this. Okay, next. Basically, differential equations are of two types. Differential equations are of two types: ordinary differential equation and then partial differential equation. Ordinary differential equation and then partial differential equation. So what is a differential equation? An equation involving derivatives. An equation involving derivatives or differential coefficients is known as a differential equation. So these differential equations are of two types: ordinary differential equation and then partial differential equation. Ordinary differential equation and then partial differential equation. So in an ordinary differential equation, okay, there exists only single independent variable. Okay, in partial differential equation, there exists more than one independent variable. You know the partial derivatives. Partial derivatives are used when there are more than one independent variable. Partial derivatives are used dou by dou x, dou by dou y. They are used when there are more than one independent variable. Okay, so an equation involving ordinary derivatives is called as an ordinary differential equation. An equation involving partial derivatives is called as a partial differential equation. For example, dy by dx plus 2y equal to 0. This is the ordinary differential equation because there is only one independent variable. Here x is the independent variable here. So there is only one independent variable. So we'll use ordinary derivatives. So we have used dy by dx. So this is the equation involving ordinary derivative. So it is an ordinary differential equation. For example, consider this one. This is also an ordinary differential equation. If you observe that here also there is only one independent variable xn. So this is also a ordinary differential equation. Similarly, if you consider this equation, dou square u by dou x square plus dou square u by dou y square equal to 0. If you observe that here there are two independent variables, x and then y. There is only one dependent variable here, u. U is the dependent variable. X and y are the independent variables. So there are two independent variables. So you'll use partial derivatives here because there are two independent variables. So this equation involves partial derivatives. So this is called as a partial differential equation. Okay. For example, second one, dou square u by dou x dou y plus 1 equal to 0. Here also u is the dependent variable, x and y are the independent variables. So this is also a partial differential equation. This is also a partial differential equation. So here in this first 2 units, we will study about the procedure to solve ordinary differential equations only. Okay, we'll solve ordinary differential equations only. Next, order of a differential equation. And order of a differential equation. D means differential equation. The order of a differential equation is the order of the highest derivative. Order of the highest derivative involving in the differential equation. For example, let us consider this equation. D square y by dx square plus 2y equal to 0. D square y by dx square plus 2y equal to 0. If you consider that the highest derivative is the second order derivative, d square y by dx square. So the order of the highest derivative is 2. Highest derivative is second order derivative. So order of this derivative is 2. That is nothing but the order of the differential equation. Order of the differential equation. Order of the highest derivative is nothing but the order of a differential equation. Next, if you consider this differential equation, so here the order is 2 only. Highest derivative order is 2. So order of this differential equation is 2. Next, second one, d power 5y by dx power 5 plus d cube y by dx cube whole power 8 plus 3y equal to 0. So if you observe that here the highest derivative is the fifth order derivative. This is third order derivative, d cube y by dx cube. So first we have to look at the highest derivative. So highest derivative is fifth order derivative. Okay. So d power 5y by dx power 5. So order of this highest derivative is 5. So order of this differential equation is also 5. So what is the order of a differential equation? It is the order of the highest derivative. So order of this differential equation is 5. Okay. So understand this definition. Order of the differential equation is nothing but the order of the highest derivative. Derivative యొక్క ఆర్డర్ నే డిఫరెన్షియల్ ఈక్వేషన్ యొక్క ఆర్డర్ అంటాం. అంటే హైయెస్ట్ డెరివేటివ్ యొక్క ఆర్డర్. అంటే ఇక్కడ హైయెస్ట్ డెరివేటివ్ ఇస్ సెకండ్ ఆర్డర్ డెరివేటివ్. సో ఆర్డర్ ఇస్ 2. Here the highest derivative is fifth order derivative. Okay, fifth order derivative. So ఇది ఆర్డర్ 5 అవుతుంది. ఆర్డర్ 5. ఈ పవర్స్ ఇవి చూడకూడదండి. హైయెస్ట్ డెరివేటివ్ ఏదో చూడాలి. హైయెస్ట్ డెరివేటివ్ యొక్క ఆర్డర్ నే డిఫరెన్షియల్ ఈక్వేషన్ యొక్క ఆర్డర్ అంటాం. ఓకే, నెక్స్ట్ degree of a differential equation. Degree of a D means degree of a differential equation. The degree of the differential equation is the degree of the highest derivative involving in the equation when equation is free from radicals and fractions. Radicals and fractions means it should be free from powers and power lo fractions lekunda undali. Okay, the equation should be made free from okay fractions in the powers. Okay, then we'll define the degree as power of the highest derivative. Power of the highest derivative is nothing but the degree of a differential equation. For example, let us consider this example. D square y by dx square plus 2 into dy by dx plus 1 equal to 0. So if you observe that highest derivative is second order derivative. Okay, so order of this differential equation is 2 only. Order 2 and power of it is 1. So power of the highest derivative is nothing but the degree of a differential equation. Okay, power of the highest derivative is nothing but the degree of the differential equation. So this differential equation order is 2, order is 2, degree is 1 and order 2, degree is 1. Order 2, degree is 1 and next, consider this example. X into d square y by dx square whole power 8 plus dy by dx whole power 11 plus d cube y by dx cube whole square equal to 0. So highest derivative is third order derivative. Highest derivative is third order derivative. So order of this differential equation is 3 and order is 3. Okay, and its power is 2. So degree is 2 and order is 3, degree is 2. Okay, so remember these definitions. Degree means power of the highest derivative. Order of the differential equation is the order of the highest derivative involving in the differential equation. Okay, so here we'll study about only first order and first degree differential equations in our first unit. Okay, so we'll study first order differential equations like this. It involves only first order differential equations. So we'll study about particularly first order and first degree differential equations. So general form of first order and first degree differential equations is this one. Dy by dx equal to f of x comma y. This is the general form of first order differential equations. Dy by dx equal to xy like that. Dy by dx equal to xy. Okay. Or x square plus y square into dx plus xy into dy. This is also a first order and first degree differential equation general form. M dx plus n dy equal to 0, where m and n are functions of x and y. So there are so many methods to solve these first order and first degree differential equations. And there are so many methods to solve the first order and first degree differential equations. You studied some of the methods. Okay, somebody has raised the hand. You can chat in the chat box, and if you have any doubt. So here in particular, we will study about a first order and first degree differential equations, procedure to solve first order and first degree differential equations. So there are so many methods to solve this differential equation. There is no general method to solve this. There is no particular method to solve these equations. There are so many methods. You solve these type of equations in intermediate also. A variable superpose method is one method. Homogeneous linear equations. Next, non-homogeneous linear differential equations, Bernoulli's equations. Okay, exact equations. These are the methods to solve the equations. You learned some of the methods in intermediate itself. Okay, you learned some of these methods. Okay, now we'll consider the first this method, linear differential equation. Procedure to solve first order and first degree differential equations. In particular, linear differential equation. A differential equation of the form dy by dx plus p into y equal to q. Dy by dx plus p into y equal to q is called as a linear differential equation, where this p and q are functions in x and a differential equation of the form dy by dx plus p into y equal to q is called as a linear differential equation. Okay, So in order to solve this linear differential equations, first we have to find integrating factor, and we'll call it as IF. In order to solve this first order differential equation, first we'll find integrating factor. Integrating factor is e power integral this p dx, and e power integral p dx. Next, solution of this equation is y into integrating factor equal to y into this integrating factor equal to integral q into integrating factor dx plus c. Y into integrating factor equal to integral q into integrating factor dx plus c. This is the solution for the differential equation. Sometimes the differential equation will be in this form also, dx by dy plus p into x equal to q. ఇక్కడ dy by dx ప్లేస్ లో ఇక్కడ dx by dy ఉంటుంది. నెక్స్ట్ ఓకే, నెక్స్ట్ ప్లస్ p into x ఉంటుంది. ఓకే, ఈక్వల్ టు q, వేర్ pq అనేవి pqr in terms of y. and in this case the integrating factor will become e power integral p dy. ఇక్కడ మీరు అబ్జర్వ్ చేస్తే dy by dx plus p into x ఈ ఫామ్ లో ఉంటే y is the dependent variable and independent variable x and independent variable x. So integrating factor lo in e power integral p dx, we have to integrate it with respect to this independent variable. Okay, na integration with respect to independent variable. Here in this case dx by dy plus p into x equal to q. X is the dependent variable, x is the dependent variable and y is the independent variable. X is the dependent variable, y is the independent variable. So in this case we have to integrate with respect to y and e power integral p dy. Okay, in this case general solution is x into integrating factor equal to ikkada y into integrating factor untadandi, ikkada x into integrating factor equal to integral q into integrating factor dy. Ikkada dx unte ikkada dy plus some constant and c anedi constant. So here remember this one, if the differential equation is in this form, dy by dx plus p into x equal to q, okay, the equation is called as a linear differential equation. In order to solve this, first we have to find integrating factor. Integrating factor is e power integral p dx. Okay, integrating factor kanukoవాలి first. Then solution is given by y into integrating factor equal to integral q into integrating factor dx plus c. Okay, this is the procedure. ఇది మీరు ఇంటర్మీడియట్ లో కూడా నేర్చుకున్నారండి ఆల్రెడీ. ఓకే, సో దీంట్లో ఒక ప్రాబ్లం చూద్దాం. ఈ ఫస్ట్ మెథడ్ లో చూద్దామండి. ఫర్ ఎగ్జాంపుల్ దే విల్ గివ్ ద క్వశ్చన్ లైక్ దిస్, సాల్వ్ x into dy by dx plus y into y equal to log x. and so solving this differential equation is nothing but finding the value of y. దీన్ని సాల్వ్ చేయడం అంటే ఏంటంటే finding the value of y which satisfies this equation. ఈ equation satisfy చేసే y value ని కనుక్కోవాలి, because y is the dependent variable, x is the independent variable. ఇక్కడ మీరు అబ్జర్వ్ చేస్తే dy by dx మాత్రమే ఉందండి, అంటే ఫస్ట్ ఆర్డర్ డిఫరెన్షియల్ ఈక్వేషన్. దీని పవర్ కూడా 1. సో దిస్ is a first order first degree differential equation. So we can write this in this form and dy by dx plus p into y equal to q form లో రాయొచ్చు. ఇక్కడ రాయొచ్చు కదండి. ఇఫ్ యూ డివైడ్ దిస్ ఈక్వేషన్ విత్ x, దీన్ని x తో డివైడ్ చేయండి. ఓకే, dy by dx you will get dy by dx plus y by x and y by x equal to log x by x. and so if you observe that this equation is in this form and dy by dx plus p into y equal to q, ఈ ఫామ్ లోకి వచ్చింది. గివెన్ డిఫరెన్షియల్ ఈక్వేషన్ is of the form dy by dx plus p into y equal to